Welcome back to the series of object-oriented programming. In the previous video, we have discussed about encapsulation in OOP. Now we move ahead to the next topic of our series. That is polymorphism. Polymorphism is a core concept in object-oriented programming that allows objects to be treated as instances of their parent class, even if they belong to different subclasses. Let me explain it in easy words when we say allows objects to be treated as instances of their parent class. It means that, if any child class is derived from the parent class, it can do everything that the parent class does, but also has extra features. You can use an object of the child class in any situation where an object of the parent class is needed. This is possible because the child class has all the characteristics of the parent class, and it can be used in its place. Let me more explain in a simple example. Imagine you have 3 toys, a car, a helicopter, and a boat. All of them are cool and do their own unique thing. The car runs on the ground. The helicopter flies in the sky. The boat flows in the water. Even though they do different things, they all have remotes with the same start button. But the result depends on what the toy is. This idea is like polymorphism in programming. Polys means many, and morpha means forms. So, it means one thing like the start button can have many forms like running, flying, or swimming. Now let us understand it in a practical example. We create an animal class that will work for like a parent object. We need a common method which we will implement in other subclasses. The subclasses will provide their own version of the sound method. Now we create a dog class, which is a subclass of the animal class. Here, we will use some methods of the animal class. Note something: if we use the method of the parent class, we need to put override keyword above the method, but implementation may be different according to each object. Let's create another subclass named cat. Here too, our implementation will be the same as in the dog class, but version of sound may be different. Now let's create main class to test our program. We use the animal class as a reference here, and assign it to the both child classes object. At the end of the example, we run our program and see the output. Our output is exactly as we want it. Our next topic is types of polymorphism. Polymorphism generally has 2 main types. The first is compile-time polymorphism, which you can call static polymorphism. We decide which version of a function or method to use before the program runs. It's like this: imagine you have a Swiss Army knife. It has different tools, a knife, scissors, a bottle opener, and before you start using it, you choose which tool you'll need for the job. That decision is made before you actually start working. But in programming, this happens in 2 main ways. The first method is overloading. Multiple methods have the same name, but differ in parameters either by the number or type of parameters. Let's try to understand in a practical example. First of all, we create an adder class. Here, we need 2 methods with the same name, but their parameters will be different in types or numbers. Now we create a main class to test our program, to see if our class works as we want. Like previous example, here we would use adder class as an object reference. In the first, we pass round values. In second, we pass decimal values. Let's test the program and see what happens. Yes, the output is as it should be. What happens here? If we give 2 rounded or decimal values, the computer knows which version of the method to call will be appropriate. It decides all this before the program runs. The second overloading type is operator overloading. The same operator is used to perform different operations, depending on the type or number of operands. The second type of polymorphism is runtime polymorphism, or dynamic polymorphism. Runtime polymorphism, or dynamic polymorphism, is when the method that gets called is determined at runtime rather than compile time. Method overriding: we have discussed this before, in this tutorial with a practical example. Once again, let me repeat: a subclass provides a specific implementation of a method that is already defined in its superclass. Upcasting is assigning a subclass object to a superclass reference. Think of animal as a big group that includes all kinds of animals, like dogs, cats, birds, etc. Now, dog is just one type of animal in that group. So when you say, this dog is an animal, you're just putting the dog into the bigger group called animal. That's called upcasting. You're treating a dog like it's just an animal. It's like saying, my dog is an animal. You're not focusing on the fact that it barks or plays fetch, just that it's part of the animal family. Now move to the next topic, that is key concepts of polymorphism. Several concepts are essential to understanding polymorphism, particularly in object-oriented programming. We will discuss each one by one in detail and have a look on their examples. Polymorphism heavily depends on inheritance because it allows child classes to inherit methods from a parent class and modify or extend them as needed. Imagine you are a music teacher and you tell all your students to play an instrument. Each student plays a different instrument. One plays the piano, another plays the guitar, and another plays the violin. The teacher represents the superclass. The students are the subclasses. The instruction, play an instrument, is the method that each subclass inherits, but implements differently: piano, guitar, or violin. Method overloading and overriding. It refers to defining multiple methods with the same name, but different parameters within the same class. Imagine you have a vending machine that sells different items, but has the same buy button. If you press the button with $1, you get a snack. If you press the button with $2, you get a drink. If you press the button with $5, you get a combo meal. Even though the button action is the same, it works differently based on the input. Our next topic is overriding. It allows a subclass to provide a specific implementation for a method that is already defined in its superclass. Let's take a look at a practical example. Imagine a parent teach their family member greeting rule. Parent greets people by saying hello. If we want to apply another class's method, we should extend the parent class. Now mother class can use parent method. Note something here. We must use override keyword above the method if it belongs to another class. But implementation may be different. The mother greets people by saying good morning. Likewise, child can follow the same rule, but he says, yo, what's up? Each one follows the same rule but implements it in their own way. This is what happens in method overriding. Each one follows the same rule, but implements it in their own way. This is what happens in method overriding. Our next topic is upcasting and downcasting. It is treating a subclass object as if it were an instance of its superclass, allowing dynamic polymorphism. Think of it like calling all vehicles. Imagine you have different types of vehicles: car, motorbike, bus. Even though they are different, you can refer to all of them as vehicles because they all belong to the vehicle category. We create a vehicle class, like the previous one. Now we create a car class and extend it to a vehicle class. Here we are treating the subclass car as its parent class vehicle. Our next topic is downcasting. It is the reverse, casting a superclass reference back to a subclass reference. Downcasting can be risky and usually requires an explicit cast. At first, you treat it generally as a vehicle. That is upcasting. Later, if you need sports car-specific features, you must explicitly convert it back. That is downcasting. Our last topic in this tutorial is why use polymorphism. Polymorphism offers many advantages that make it a valuable concept in programming. Code reusability: you don't have to write the same function multiple times for different types of objects. Instead, you can write one function that works for all related objects. Easier to maintain and expand: if you need to add new features, you can do so without changing a lot of existing code. More flexibility: your program can work with different types of objects in a general way, making it more adaptable. Simplifies code: instead of using many if-else statements to check the type of an object, polymorphism automatically selects the right method at runtime. Better testing: since different objects can be tested with the same function, it makes testing easier and more organized. It was all about polymorphism. Goodbye, happy coding.